Assalamualaikum and good day everyone. My name is Dr. Najiha Muhammad. I will explain the technique called separable by substitution, which is under 1.4. Okay, so now this is all the topic in chapter 1. So by now all of you maybe have covered 1.4 separable equation. Actually, under the separable equation, we have two categories, which is the first one is the basic one, and the second one is the separable by substitution. Okay, so I hope you can recognize the differential equation, which is originally is the separable equation, but the other one is non-separable that we can reduce to the separable equations. Okay, so in the previous example, meaning the previous lecture, which is basic separable equation, the differential equation are separable. However, there are also inseparable differential equation. Okay, inseparable meaning it is not separable, that can be reduced to separable equation by appropriate substitution. Okay, so now we have one example. Okay, I want you to look at this first. dy dx equals to x plus y divided by 1 minus x minus y. If you notice carefully, this is non-separable, right? We cannot separate the x and the y for each side without mixing the variable, right? Okay, but this kind of question is very straightforward. By using a substitution equation z equals to x plus y, find the general solution. Okay, even though they are not mentioning whether you have to use separable or homogeneous or linear or what else is that, but since we still inseparable, clearly we have to use the separable one. Okay, I want you to understand that for the real world application, maybe you just facing the differential equation, and then you have to recognize which method that can be used. Okay, but in this subject, we will give to you the substitution equation. This one will be given, so you don't have to be worried. Okay, so now we will discuss the method. Okay, I have copied the question here. New page. Okay, the first one is we copy back the equation x plus y. Okay, this one we label as equation number 1. This one we label as A. Okay, and then we differentiate equation number 1 with respect to x. dz dx equals to 1 plus dy dx. Okay, this is equation number 2. And then substitute equation 1 and equation 2 into equation A. Okay, so then clearly we have to manipulate a bit. So we know that dy dx equals to dz divided by dx minus 1. So this label goes to here. Okay, I hope you can see what I'm doing. Okay, I highlight first one. This is the given substitution equation, and this one is the second equation, which is coming from equation number 1. And then I have rearranged so easy for us to substitute into equation A. Okay, so then alright, so look at the question. I copy this one so easy for us to see. Okay, over here I think it's not far. Okay, never mind. Okay, so then dy dx. Okay, dy dx will become dz dx minus 1. Okay, equals to okay, x will remain, okay, sorry, clearly x plus y equals to z, isn't it? This is very clear, so this will become z. Okay, this one, if we simplify, we will have 1 minus bracket x plus y, isn't it? So this one will be 1 minus z. Okay, so we do expand a bit. Z minus z plus 1. This one, merge this one, z plus 1 times 1 minus z divided by 1 minus z. 1 minus z. Okay, so it will become z plus 1 minus z, isn't it? Yes, divided by 1 minus z. Okay, and then simplify, it become 1 divided by 1 minus z. This is dz dx. Okay, so now we continue the process. This will become dz dx equals to 1 minus z. Alright, then this 1 minus z dz, okay, 1 dx. Okay, clearly I forgot to tell you that this one, at this level, this one is separable. We have managed to reduce the original question to the separable one. Okay, so now okay, you just have to integrate both sides. See, at this side we just have z, at this side we just have y, even though we don't have any x over here, right? Okay, so this one, z minus z squared per 2 equals to x plus c. Okay, so this is the general solution in term of z and x. But remember that we have to replace back because the question is in y and x, isn't it? So remember z equals to, okay, I want to check back, z equals to x plus y, x plus y. So we replace this one into the question. So x plus y minus x plus y squared per 2 equals to x plus c. Okay, I can say this one is the general solution, but you have, remember, you have to simplify until you have the simplest presentation of answer. So y minus x plus y squared per 2 equals to c. So done. This is the answer. Okay, so class, this is the last presentation of mine, but over here in this slide they are using different presentation, meaning they are expanding everything. I want you to know that at this level we have to able to recognize which one. I can say both is accepted. This one also accepted, this one also accepted. Okay, but make sure you know what is simplification. Okay, this is also simple, and this is also, I can say, simple as well. Okay, so now we do maybe one example for from these exercises. Maybe we can try question B. Question B, we try question B, right? Copy. Okay, so alright, so first equation, z equals to 3x minus y minus 3. This is equation 1, and then differentiate dz dx equals to 3 minus dy dx. Okay, differentiate 3 will become 0, so I don't write that. Okay, and then we simplify. Dy dx equals to 3 minus dz dx. Okay, this is equation number 2. Okay, so now we substitute equation 1 and equation number 2 into the A. I name this one as A. The A. Okay, I just want to, for us to easy to call the equation. Okay, so then 3 minus dz dx equals to okay, obviously. Alright, so now you have to focus on, we have 3x minus y plus 3. Okay, so how is that? Because this one, the z equals to 3x minus y minus 3. Okay, think clearly, think creatively. Okay, so actually this one, okay, I just copy back 3x minus y plus 3, 3x minus y minus 1. Okay, so then over here, okay, I pick this one orally first. Okay, you have to make sure you have these terms. Okay, make sure you have this term, so easy for you to just replace the z by z. Okay, so that is the main idea. Okay, so then I put 3x minus y minus 3, but the original equation is plus 3, so how to balance back? I put plus 6, so it is equate to this, right? Yes. Okay, so then next is 3x minus y minus 3. Okay, I want to balance back, so I put my plus 2. Okay, it balanced. So then we just replace by z plus 6, z plus 2. This one 3 minus dz dx. Okay, so then alright. Okay, so I bring this one to this side. I copy back 3 minus dz dx equals to z plus 6, z plus 2. Okay, so now we make some manipulation. I hope you can see what I'm doing. Okay, I move the dz to dx to the other side, and then but I switch back the at the left side. Okay, whatever, this is the result. I will have 3 minus z plus 6, z plus 2. Okay, done. Okay, then okay, check back. I bring this one to this side, and I bring this one to this side. Okay, done. And then merge 3 z plus 2 minus z minus 6. Okay, z plus 2. 3z plus 6 minus z minus 6. Z plus 2. Simplify. 2z. Z plus 2. Okay, be careful with my 2 and my z. I can see clearly my z, and I can see clearly my number 2. Okay, so then over here, I just carry this one. Okay, and then over here I will do the separation. Plus 2. This one is separable. Okay. Okay, then I just bring my z, and then I leave my 2 over here. Okay, okay, look carefully. I leave my number 2. This is my number 2, right? I leave my number 2 at this side, and then I bring dx to this side, and then z plus 2 per z. I bring to this side. Okay, it's up to you whether you want to bring the number 2 to the left side or not. It's up to you. But this is my work step for now. You can have yours. Okay, and then I copy back z plus 2 per z dz 2 dx. Okay, I do the simplification. 1 plus 2 per z dz 2x plus c. Integrate this one, z plus 2 ln z. Okay, 2x plus c. Okay, so now what else to do? Okay, z plus ln z squared equals to 2x plus c. You want to replace or not? It's okay to replace the z now. Remember that I change the color first. Z equals to 3x minus, I don't remember, so I have to recall back 3x minus y minus 3. Minus y minus 3. So we have to replace that one back. Okay, maybe we do further step. Z, sorry, not Z. Ln, we change the color first. Ln z squared equals to 2x minus z plus c. So z squared equals to exponent 2x minus z plus c. Okay, I copy this one back. Z squared equals to EC E 2x minus z, which is a exponent 2x minus z squared over here. Okay, I replace this one. I will replace over here. I use red color. 3x minus y minus 3 squared equals to a. I don't have enough space, so I will put down here a exponent 2x minus 3x minus y minus 3. Okay, we simplify a exponent y minus x plus 3. Okay, so this is 3x minus y minus 3 squared. Okay, we can leave our answer like this. Okay, this is not the end yet because we can do some simplification, which is Ka exponent y minus x exponent 3, isn't it? Okay, remember that I copy this one over here. A exponent 3 we can have as b maybe. So we can have b exponent y minus x. Okay, so that's all. We copy this one, minus y minus 3 squared. So this is the answer. I highlight this one. This is the final answer, as the b equals to a exponent 3. Okay, done.